Two quantitative variables, linear regression. So linear regression is a technique of looking at a set of x and y values that we claim are related and coming up with an equation, and the equation is of a line. So standard line is y equals mx plus b. So a couple of reminders about this. This equation right here is known as the slope-intercept equation for a line. And it tells us two things, the slope, m. And remember, slope is rise over run. So if we have some line and we have 2 points on that line, slope describes how to rise and run to get to that other point. Now, it could be the line is downhill. We talked about earlier, negative correlation. And so in this case, the rise would go down and then run would head over. We can actually go in multiple directions. So instead of going from this point A to point B over here, I could go from B to A, in which case I would rise up, but go left, which would be a negative. So suppose, for example, in this picture that this was on this side a drop of 2 and maybe a run of 3, right? I went down 2, that's negative 2. I went right 3, that's positive 3. So that slope right there would be negative 2/3. Here, though, I'm saying go up 2, but then left 3. So I could also write this slope as 2 over negative 3. So whenever you have a negative fraction, that negative could be attached to the numerator or the denominator, but not both. Sometimes you'll see it written in front, though. So it could be like negative 2/3 if I have a fraction. This one up here, let's suppose we have something like up 0.6 and then right 1. So that slope right there, m would be 0.6 over 1 or just 0.6. And we could go the other way. So I could say from this point, go down, drop, and then left. So a positive slope could be viewed as a negative over a negative. So it would be a drop of negative 0.6 followed by going left, negative 1. Negative divided by a negative is still a positive 0.6. Sometimes with slope, we have 2 points and we want to actually calculate it. And you might have seen this y2 minus y1 over x2 minus x1. We're really not going to need that too much. We just need to remember that slope is rise over run. It's our vertical change over horizontal. And down here, horizontal change. Y-intercept, B. Y-intercept is actually a point, not just a number. So I would write it as 0, comma, B. And so it's the place where x is 0. So just think about a graph for a second. We have a line that does something like that right there. The y-intercept is that point right there. And on the y-axis, you haven't gone left nor right as far as x is concerned. So that point right there is the point 0 for x, whatever b is for y. So it's a point. So when we talk about it later in a specific problem, although we just write the number b, for y, x is 0. And often the y-intercept, we interpret that as a starting or initial value. And for most examples, we're just going to have a computer find the equation of the line for us, which means it's going to tell us what m and b are. So let's first take a look at StatKey, example of this. So StatKey is a website that accompanies our book. And from the StatKey homepage, I'm looking at two quantitative variables right now. First example on their list of variables is Florida Lake's mercury versus pH. I explained that in a previous video what it meant. The pH is samples of each point of a particular lake. And so this one right here, the pH of the lake was about 5.2, which is a little basic. And then the average mercury was 0.25. And the measure of the average mercury came from they caught a bunch of fish and then biopsied or something with the fish and measured how much mercury they had in their systems. And so this is the average of several fish. And so we can see here that there's kind of a cloudy downhill trend. You can hit show line and it draws that line through here. And StatKey calculates a whole bunch of things for me. It gives me a mean standard deviation for pH, a mean standard deviation for average mercury. I'm not going to use those this time. It tells me there are 53 samples here, so 53 points. They're giving me a correlation, an R, a slope, and an intercept. So I'm just going to grab some of this data and the graph. Actually, let's just grab it all and figure out what it tells us. So this is from the Florida Lakes data sets, and we are looking at pH versus average mercury. The pH is in the horizontal, so that would be my x-axis here. So x, in this case, is the pH of the lake. And over here, my y is the average mercury. And they're telling me the coefficient, the correlation coefficient R is negative 0.57. So it's not very strong, but it's not too weak either. And evaluating that further is beyond the scope of this course at the moment. It's negative, which means there's a downhill trend there, negative slope. And here I can see the slope next to it, negative 0.152. So as far as the line that they have drawn in red there, usually when we graph a line like that, we don't call it y, we call it y hat, or a model, not the actual y values, which is the mercury is the actual y, the measured one. We're writing an equation for it, so we give it a slightly different name. And remember, y equals mx plus b, the type of equations we're looking at, and here we're told the slope is negative 0.152, and the y-intercept is 1.531. So that is my linear model. Now let's try and figure out what the slope means. So slope, remember, is rise over run. My rise is the average mercury. So the rise here is then a change in average mercury. And the pH is the run, so that is a change, right? Because slope we have to subtract to get the numerator, subtract to get the denominator, that's the change. pH. My slope here is negative 0.152. To write that as a fraction, I just write over 1. The top here is a change in mercury. The bottom here is a change in pH. So what this tells me is the 1 is positive in the bottom. Negative over positive gives me a negative slope. So a change in pH of +1 leads to a decrease in mercury. So often you're going to be asked to interpret the slope in a situation like this, which means tell me what it means in terms of the given variables. Now, if we don't know how these variables are measured, we got a problem. So I just want to double check average mercury. Did I ever find a good definition of that? Let's see, I looked it up earlier. Give me a sec to find it here. milligrams per gram in the tissue, and it was largemouth bass that they caught. So I had to look this up. It's in our, they talk about this in the book about how it was measured. And so if we don't have that, then we just kind of have to fake it. But it's milligrams of mercury per gram of muscle mass in the fish. We'll just say it's milligrams, or actually, μg is micrograms, excuse me, not milligrams. So we'll just say it's micrograms of mercury. So to interpret the slope here, I just want to write a statement that takes into account this change, that change in their units. And generally, when we do this, we have an independent variable or explanatory variable. So independent, explanatory, and then the y value is often called the dependent variable, response variable. So we think pH affects the mercury, that it depends on it, responds to the amount of what the pH is, how acidic or basic the water is. So I think then the interpretation would be something like this: an increase of 1 for the pH of the lake leads to a decrease of, I'm going to say about 0.152 micrograms of mercury on average in fish, is what that tells me. And again, in order to describe that, I have to get a definition of what each variable means. If we don't have a definition of the variables, we can't explain what the slope means, so the whole thing is pointless. So a couple of things here. One, StatKey, given a set of data, will easily give us the slope and the intercept, and we can come up with the equation for the line. Then we want to be able to state what the slope means. That's pretty important. Y-intercept's not as important. I think the slope's more important. If we wanted to interpret that y-intercept, we could. Remember, y-intercept is a point. It's always 0 for x and whatever we're given for the y-intercept, so 1.531. And so this right here would be the pH, and this right here would be the micrograms of mercury. I don't think fish could survive in a lake that has a pH of 0, but I'm not a biologist. So this could be a meaningless number, but the interpretation would be, now these aren't changes, these are actual values. So if a lake had a pH of 0, you would expect the average fish to have about 1.531 micrograms, sorry about that, mercury. And if we look at the data though, oops, here, the lowest pH we have is a 3. So the y-intercept's really just there to put the line in the right spot. An actual pH of 0 doesn't exist in the real data. So although I can interpret it, it may not be a meaningful interpretation. The slope, however, is always a meaningful